So thanks for having me in tonight. It's great to talk to you guys. I heard mention of the skyscrapers, and you guys have visited Lowell. I remember hosting a tour or two. It seems like it's been a few years, but seems like two, so it's probably been 8 or something like that. But it's been a while. But I'll just leave this as an open invitation, either as individual or a group. If you want to come to Lowell, let me know. And I'd be glad to help coordinate your visit and show you some behind the scenes stuff that you might not see on the normal tour. So it's, it's for me, it's an honor to be able to share this stuff with people that are interested. And so if we can go exploring behind the scenes a little bit, that's a lot of fun in addition to the regular stuff. So just keep that in mind.
Great.
So,
can you leave your email address, please?
Sure, I'll put it in the chat right now so I don't forget. And it's real easy. It's just kevin@lowell.edu. Yeah, so there it is. So I've been at Lowell almost 27 years now. And I started as a tour guide here. My background is geology and paleontology. So I used to look down, but for the last almost 3 decades now, I look up. I managed the outreach program here for a decade or so. And now I work in the marketing department as the historian. So I do a fair bit of writing and speaking about the observatory and write our press releases about science stuff going on. And, it's great because we have so much going on at Lowell, and we're growing so rapidly that there's a lot of things to talk about at any given time. So what I thought I'd do tonight is introduce the observatory. First, talk about the founding of the observatory, how we ended up here in the first place, and then talk about the science, and then talk about the outreach, and then talk about the plans we have moving forward for our outreach program, because our current facilities we've outgrown, and we're now in the process, as I mentioned earlier, some of you may have heard, we're in the process of building a new visitor facility that'll be 3 stories, a rooftop open planetarium, as it's being called, 200-seat theater. It's really going to be cool, and I'll show you a sketch of what that's going to look like. So let me start my program here, and there should be a title slide now. Okay, good. We're off to a good start. So we'll just go through again. This is pretty informal, and it looks like I'm not seeing the chat, and let me see if I can open it and I'll see it. Okay, I can see it here, so I'll try to pay attention to that. But otherwise, it's pretty informal, so ask questions as we go. So I want to talk about what Dave Eicher, and many of you know Dave Eicher either personally or by name. He's been the editor of Astronomy Magazine for decades now. He's the one on the right. And Dave is on our advisory board here at Lowell Observatory also. But in recent years, he's given Lowell the nickname America's Observatory, because we've got this really great heritage of research, but that research is continuing today better than ever. Plus, we have a really strong education program to try to inspire people of all backgrounds to look up at the skies, and wonder about the universe. And so Dave has used this term, and it's kind of caught on. So I want to talk about why he's called us this. In this picture, by the way, is Dave, some nerdy guy who got in the picture. And then that's Brian May on the left, who many of you know is an astrophysicist who was involved with the New Horizons mission and also plays guitar on the side for
a little bit.
band Queen. Yeah, it's a really remarkable story. His background: he was working on his PhD in astrophysics just about the time he started the band Queen, and they just took off. So he put aside his studies, and then I don't know, a couple decades later, Patrick Moore, who he was friends with, said, "You really should go back and finish your PhD," which was on something about zodiacal light. And so he went back and finished his PhD. So maybe not the typical rock star you associate with, but he's been up here to Lowell and is involved with some science projects today. So let's go back to the beginning of the observatory, and even maybe a little bit before the beginning. Before I do that, I want to just mention a connection. Old Lyme, I think, is what, 45 minutes or so from Hartford. And this fellow grew up in Old Lyme. His name is John Hall, and he was the director here at Lowell Observatory in the mid 60s to, or early 60s to late 70s, early 80s. And in fact, there's a telescope here named in his honor. The pride of Old Lyme, Connecticut, was our director for a long time, and a really marvelous person that really was critical to the observatory, because for years, the observatory was, after the discovery of Pluto, there wasn't much going on in terms of science. And John Hall came in and fired people up and said, we have to get external money to keep going. We have to get back to doing real science. And he's really responsible for bringing us into the modern era. So he's really a revered character here at the observatory. Another character here at the observatory that you'll be familiar with is Percival Lowell, our founder. And Percival Lowell is a fascinating character, I think, because he came from a mainstream family, but a lot of his ideas were anything but mainstream. They were outside the realm of what a lot of astronomers thought was practical or realistic. And I think this goes, if we have to look back at his background a little bit in his family to understand, this guy that was self-taught, very intelligent, driven, very willing to share his ideas, even though they didn't go by scientific norms. And in hindsight, we know a lot of his ideas, like the very nature of canals on Mars, we know don't exist. And his theories about intelligent life on Mars, it's just not the case. And yet he made such a compelling case for a lot of this stuff that he's still remembered as a father of planetary science in some ways. He really had a great impact, and it's remarkable. So I thought I'd just talk about him a little bit because without him, there is no Lowell Observatory. He was born in 1855 back in Massachusetts. And later in life, he recalled that his earliest conscious memory was seeing a comet when he was 3 years old, Donati's comet of 1858. That was his earliest recollection. And here's a sketch of Donati's comet. And this kind of inspired his life. He would go into mathematics, but he always had an interest in astronomy. His mother got him his first telescope that he would set up on the roof of the family home in Brookline, Massachusetts. And he would go to college for mathematics, but his senior thesis was on astronomy, the nebular hypothesis. And so, sorry about that. And so he grew up with this interest in astronomy, but there's also something else that really drove him, and that was expectation. He was from a very well-to-do blue blood family, the Lowells of Massachusetts, and Percival's father instilled an expectation in him that was passed down through the generations. If you were a Lowell, you were to make an important contribution. And that was very, very well beaten into the kids. And, in the family, they had lawyers and judges and writers, poets, generals in the wars. And it was just a very accomplished family, very well-to-do family. Percival Lowell's generation itself, he was the oldest. His brother, his younger brother, Abbott Lawrence Lowell, would go on to be president of Harvard for 24 years. One of Percival's sisters married a relative of Theodore Roosevelt. Another sister won the Pulitzer Prize, Amy Lowell. So this is a very accomplished family. And I think this is an important thing to keep in mind when we look at Percival Lowell and him going into astronomy, because after he got out of college and he worked for the family business for years, he didn't go into astronomy yet. He had an interest in it, but he first worked at the family business for years. But he was a wanderlust. He wasn't interested in sitting in an office all day, and yet he wanted to do great things. And so for nearly 10 years, he got out of college, worked for 8 years in the family business, in the textile business. And then he went overseas and spent a decade in Korea and Japan, and was one of the first Westerners to really immerse himself in their society. But he didn't just immerse himself, he wrote about this. He wrote several books about his experiences because, again, he's a Lowell. He can't just live off the inheritance. He has to do something important with his life. So he's going to learn Eastern culture and write about it. And while a lot of his ideas were typical of 18th century thought and have evolved some, he's still very well respected and remembered in the Orient. And in fact, there's one of our advisory board members here at the observatory was over in Japan a couple of years ago, and he brought me back this package of cookies, and the package had Percival Lowell's picture on it, because they still respect him. He's sort of a hero in some parts there because he took the time to learn about Eastern culture. And so he did make a name for himself, but it wasn't big enough. He was a Lowell, he was driven. He came back to the United States after 10 years and had to decide, what's he going to do now? He doesn't necessarily have to work for a living, but he has to work at something to make his mark. And so he got interested in Mars and the supposed canals on Mars. In 1877, during a particularly good opposition of Mars, the year that S.F. Hall discovered Phobos and Deimos, that's the year that Giovanni Schiaparelli in Italy also detected these linear markings he thought he saw going across the planet. And Percival Lowell and others believed these to be waterways, that there were intelligent life on Mars. What else? Linear markings going across the planet like this are not natural. They must have been built by intelligent life in his idea, in his thought. And so, Mars, he figured, was a dead, dying planet. They were bringing water from the ice caps up to the rest of the planet to feed or to water the intelligent life there. Now, Percival Lowell wasn't the first person to see the supposed canals. And I should point out that Schiaparelli used the term canali, which more accurately relates or translates to channels, which is more of a natural feature. But Percival Lowell intentionally used the word canal because they appeared to be linear. He equated that with intelligent life. And so he got really fascinated with this. He wasn't the first one to see the canals, supposedly. He wasn't the first one to suggest that they represented an intelligent life, but he sure became the loudest, the biggest proponent of this. And he decided he's going to found his observatory. And again, I think going back to this pressure on him to succeed, he didn't begin an observatory to look at seasonal changes on Mars over time. He started the observatory to prove there's life on another planet. If he did that, that would be really cementing the Lowell name. And so that's why I think he started, was to really make that name for himself. And so he wants to found an observatory. It's late 1893, early 1894. And he goes into the Harvard College Observatory, talks to the Pickering brothers, E.C. and William Pickering, and they suggest, we have a problem here with observatories because traditionally observatories were put where the universities are, where the large cities are. In the United States at this time, that meant the East Coast. But we were getting, pollution from factories, in fact, from Percival Lowell's own factories. And there was also light pollution. And the electric lights were becoming widespread in the late 1890s, or the 1890s. And this was, shining light up in the sky. And Percival Lowell realized, we can't put an observatory here. We've got the smoke and light pollution. I'm going to put it somewhere else. He sort of considered going to South America, but didn't want to go that far away, and decided on Arizona territory. This is 1894, 18 years before Arizona is even a state. So the train is out, train is coming through town in a couple places, it's coming through the territory, but there's no electricity here. It seems like a good place, high elevation. And so Percival Lowell hires an assistant. His name is Andrew Douglas. And he hires Andrew Douglas to do some site testing, to go out to Arizona Territory, take a 6-inch refractor or Clark refractor and a bunch of weather instruments and measure meteorological conditions and test the seeing at night. I'm looking at stars and planets and such, and find a place that has, good conditions for astronomical observing. So in the spring of 1894, Douglas heads out to Arizona. He goes to Tombstone, Tucson, Tempe, Prescott, several places. This is a stop in Tombstone, and this is the 6-inch refractor. This is just a gorgeous instrument, and this is now on display in our collection center. In fact, just a side story on this. When I got here in the 1990s, this telescope was on the side of the 24-inch refractor, sort of serving as a guide scope or spotter. It was mostly there because there was nowhere else to put it. And it's this gorgeous brass Clark telescope. And so in the early 2000s, we decided to create an exhibit about the founding of the observatory. And I thought, wouldn't it be cool to put the telescope on display rather than just sitting on the side of on the big telescope where people can't really see it. And so we took the telescope off the main one, but we needed a way to mount it, because this mount was probably long gone. Well, one day I was up in the attic, and Lowell Observatory has attics like so many old places where you go up there and it's a treasure trove if you can get through the stacks of books and equipment and everything else. And I was up there with a colleague, and we found this stack of old tripods that were all dried out. And I had a picture of this. I had this picture, in fact, with me. And we looked and said, my gosh, that's the tripod. One of the tripods we found was this one. So one of our guys, Ralph Nye, spent about 50 hours refurbishing that tripod. And the telescope, 100 years later, was reconnected with that original tripod. And again, you can see that when you come to visit the observatory. So anyways, Douglas takes this telescope around the territory, tests different sites. One of the sites he tested in Tempe was on the side of this butte called Tempe Butte. And I think we're all grateful that they decided not to put the observatory there, because that's now the site of Arizona State University's football stadium. And that would have been a very lousy place to put the observatory. But Douglas spent several weeks around the territory. Really, the site testing should have taken place over a couple of years to see seasonal changes and such. But Percival Lowell, patience wasn't a virtue for him, and he was in a hurry. He wanted his observatory set up, so kept egging Douglas on. Douglas finally said, let me try one more place in Flagstaff. He came to Flagstaff and set the observatory up here, and we've been here ever since. Flagstaff is at 7,000 feet elevation, so it's a pretty good elevation. The seeing was really good here. There are about 800 people in town, and the observatory, Percival Lowell chose a hill right above the community, but there's no light pollution, so it didn't really matter. So we put it right up here so it would be convenient to get to. And it turned out to be a really good site, but looking at this expedition that Douglas took and the prodding of Percival Lowell, I'm convinced that if the conditions in Flagstaff weren't that much better than other places in Arizona, and in fact, for that few days that Douglas was in Tucson, the weather wasn't great. And we know today Tucson is a mecca for astronomy. I think that if Douglas, for whatever reason, had started his expedition in Flagstaff and then headed south, there's a really good chance that the observatory would be down south, because that's where Douglas was when Percival Lowell, who was short on patience, finally said, okay, is Flagstaff good? Let's just set it up there. So I think if we replayed it, it might not be here in Flagstaff, but it was set up here. And Percival Lowell, to start his observations, he had the 6-inch refractor, but he wanted bigger telescopes. So he borrowed this dome from Harvard College Observatory, and he borrowed a 12-inch telescope from Harvard and an 18-inch refractor from John Brashear and had them dually mounted. And he used that for the first season. And after that first season, found that it really can snow a lot in Flagstaff. And so he closed it down and almost relocated the observatory because the weather was so bad. But he decided not to. While the following year, in 1895, he returned the borrowed telescopes and ordered a 24-inch refractor from Alvin Clark, and then figured out where to set that up. Initially, they set it up right on the exact same site here. They took it down to Mexico for about a year to use it for good opposition to Mars, and then brought it back up here, and it sits on the site where this dome is now. In fact, if we look at this transition, this is the Clark dome. This is the same dome that sits today. It looks different because at first it had this canvas top, and now it's covered with wood and metal, and the walls are different, and the base has rock around it. But this is the dome. And I'll go back to this previous picture. You can tell it's the same location. You can see the tree on the left and the tree on the right, and the one in the upper corner. And if we forward again, this tree's been cut off a little bit, but you can see it's in the same location. And so the observatory is set up here. Percival Lowell considers going somewhere else, but stays here. And that's the beginning of 125 plus years of observations made here. And through the years, we've had a lot of research. Percival Lowell continued his studies of Mars. And he also started looking for a planet because he wasn't having any success proving the existence of life on Mars. And so discovering another planet, again, that would do well for the Lowell name. So he began searching for a planet in 1905. The planet he nicknamed Planet X. And he never lived to see its discovery. But after his death, we'll talk about this in a little bit, a planet he thought was out there actually doesn't exist, but they happen to find a different planet there. And we'll talk about that in a minute. So we've got the founding of the observatory. I think it's an interesting story because it wasn't a done deal. It could have gone to a different site. It could have been moved through the years, but it wasn't. And at this point, it's not going to move. I don't know what it would take to move the observatory now. So I was saying before that Dave Eicher has called Lowell America's observatory because of this heritage. We've been doing science for a long time. So we not only have the history of doing science, but we're still doing cutting edge science today. And then sharing the results of that science with the public. One of Percival Lowell's ideas was, I want to do science, but I want to make it accessible to everybody. What's the point of doing it if we don't share it with people and get people excited, non-specialists, get them excited about space? And so that was really a part of the observatory since the beginning. So let's first look at the science, and then we'll talk about some of that outreach and education. From the beginning of time here, Percival Lowell was interested in Mars, but he was also interested in other solar system bodies, including comets. And in fact, comets have been a topic of study here from the beginning through today. And one of our astronomers, Dave Schleicher, has been studying comets here since the 1980s and continues to monitor them. And he has so much data to reduce, going back to even Halley's Comet in 1980s. He still has data that hasn't been processed yet because they constantly have new comets to go out and observe and collect the data, and they process it and write about it as fast as they can. But I wanted to show this picture of a comet. You might have seen this in old textbooks. This was a pretty common picture to see. This was taken on a camera that was mounted on top of the 24-inch refractor in 1910. This is Comet Halley. And it wasn't taken through the telescope, but just camera mounted on top. But it's a remarkable picture because it not only shows, the comet and the star field, but there are city lights of Flagstaff as it began to get lights. There's the planet Venus, and there's also a meteor shooting through the field of view here. There's no airplane in the field of view. That would have to wait a few years. but other than that, it's a pretty remarkable picture. And we have thousands of images of comets taken through the years, like Halley's, but so many more. And when we talk about research at Lowell, certainly we think about Percival Lowell's Mars research, which was very controversial, but we also think about the discovery of Pluto, which was certainly perhaps the most well-known discovery, but maybe the most important discovery scientifically was the work done by this guy, Vesto Melvin Slipher, VM Slipher. In the late 1908, 1909, Percival Lowell was had purchased this spectrograph initially to prove the rotation period of Venus, as well as to look at the atmosphere of Mars and other planetary bodies. Well, by the 1908, 1909, he wanted VM Slipher, one of his assistants, to master using this instrument because he wanted him to look at some bodies in space that were pretty nebular, and they were called spiral nebulae. And Percival Lowell and others believed them to be protoplanetary systems, young planetary systems. And he thought if Slipher can take spectra using spectrograph, if he can take spectra of these fuzzy blobs, and if the spectra match those of Jupiter and Saturn and the other gas planets, then that would prove the connection that gas cloud, those spiral nebulae, probably are young planetary systems if their spectra match up. Well, Slipher did this, and the spectra didn't match. They were made of different elements. I mean, there was some match, but it wasn't the right signature. But what Slipher found was something remarkable. He found that these fuzzy objects in general, some were moving towards us, but most of them were moving away at incredible speeds. He didn't know what to make of this, but he announced observations of several of these at a science meeting in 1914 at the American Astronomical Society meeting, and he got a standing ovation for it, which is pretty unusual at a science conference, because the scientists realized, wait a minute, if these things are moving that fast, like 900 times the speed of sound and faster, if they're moving that fast, the universe must be much vaster and much older than we ever thought. What Slipher was looking at, we know today, were galaxies, and this was the first evidence of the expanding nature of the universe. This completely changed astronomy, and astronomers didn't understand what this meant for years, not till Edwin Hubble in the 1920s, using methods of measuring distances and his own observations and observations of Slipher, did he put it all together and make sense that the universe is expanding. But Slipher made the first observational records of this. So this is probably, if you look at just the science, I mean, you could argue, Pluto was a prototype of a new type of body in the solar system, these icy bodies out there. And it's certainly generated a lot of interest in astronomy. The first evidence of the expanding universe has really changed astronomy forever. So that's one of the most important discoveries here. Remember I mentioned Percival Lowell, going back to him, and this wasn't his project. He was still alive while this was happening, but this was Slipher's project. Slipher was trying to look for something else, that connection between the planets and the spiral nebulae, and he discovered something else, which so often happens in science. Well, remember I said that Percival Lowell, he wasn't getting anywhere with proving life on Mars, and I think he was getting probably a little bit down on this. By 1907, the majority of the science community thought he was just wrong. There is not intelligent life there. Even Alfred Russel Wallace, who, along with Charles Darwin, had come up with the idea of evolution, he wrote a whole book discounting what Percival Lowell had said about life on Mars. And so Lowell started getting into another big project, looking for a planet. He first published it in 1903 in this book, and then he started searching in 1905. for this theoretical ninth planet he believed was out there. Initially, he thought it was there because of behavior of meteor showers and comets, but then he got more mainstream ideas that had to do with perturbations of regular movements of Uranus and Neptune. And so he began searching for this planet. In 1916, he died, never having discovered the planet. And little did he know that one of his assistants actually captured pictures of Pluto the year before Percival Lowell died, but they never saw it. There were these cruddy little dots on the photographic glass plates, not very good plates. Not until after Clyde Tombaugh discovered Pluto in 1930 did astronomers go back on the old plates, and when they had an idea of where to look, and they discovered that Lowell's team actually had photographed it. So it's sad in a way that Lowell, it was right before him, but he never saw it. But anyways, the observatory, after Percival Lowell died, it went in the doldrums for a decade. There was no money coming in. There wasn't much research because there was no money. Percival Lowell's will was contested by his widow. But finally, after a decade of being just almost a dead place, the will was settled. The observatory had a new leader, a sole trustee, Percival Lowell's nephew. And he said, his name was Roger Putnam, and he said, we have to re-energize the observatory. Uncle Percy was looking for a planet. Let's recommence that search. And if we can discover this planet he thought was there, this will get Lowell back in the mainstream of doing astronomy. So in the late 1920s, the observatory talks to Percival Lowell's brother, Abbott Lawrence Lowell, president of Harvard. He donates money to build a 13-inch astrograph, a telescope specifically for imaging the sky, to survey the sky. And while this is happening, this is just such a great part of the unlikeliness of this. While V.M. Slipher, the director, is building this telescope, he's trying to figure out who's going to actually do the search, because there's only 3 scientists. There's him, he's the director, and he's doing some of his own research, but this isn't his kind of research. His brother, E.C. Slipher, who was an expert on planetary photography, and in fact was one of the first astrophotographers to do image stacking, to develop that technique. He was actually in the state legislature in Phoenix, so he wasn't doing much science at the time. And then one other assistant, Carl Lamplin, they needed somebody else to do the grunt work of systematically photographing the night sky and then analyzing the photographs on glass plates on this machine called a blink comparator. And just as Slipher is sending mail to colleagues around the country asking if anybody has either any money to support a position or a person in mind, he gets this letter from a 23-year-old farmer in Kansas named Clyde Tombaugh. And Clyde Tombaugh, what else is there to do on the farm at night? He studies astronomy. He's a self-taught astronomy guy. He built his own telescopes. Most of you know the story of Clyde well. And he made these drawings of planets. They're pretty good. So he thought he'd send them to Lowell Observatory because that was historically a planetary observatory. Send them there to see what they thought. And he sent them just at the time V.M. Slipher is looking for help. And so Slipher sends back a letter and asks Clyde Tombaugh things like, what kind of shape are you in? Are you in good physical condition? Are you used to staying up late at night? These sort of things. And what came out of that was an invitation to come to the observatory to work. And so Clyde Tombaugh arrives here, self-taught, but he did a good job of teaching himself. And he arrives to initially to help with the search, and then he took over the whole thing. He did the photography, he did the analyzing on the blink comparator. And in February 18th, 1930, at the age of 24, he discovers the planet we know today as Pluto. And it's remarkable. It's a great American story, I think. The guy from the little town, the unlikelihood of him getting this job in the first place, the timing that, if he had sent those drawings a year before, a year after, he wouldn't have been hired. They wouldn't have been looking for somebody. It was just great timing. So February 18th, it makes the discovery. They keep it, the observatory keeps it quiet for several months, or several weeks, sorry. They want to study it before announcing to the world they discovered a planet. They want to make sure they have a planet first. So they study it for several weeks, feel pretty good about it. So on March 13th, 1930, they announced the discovery of this new planet. And they chose March 13th because that was the date in 1781 that William Herschel had discovered Uranus. And it was also would have been Percival Lowell's 75th birthday had he lived long enough. So it was a really nice tribute to Percival Lowell. And they announced the discovery of this planet and it made headlines around the world. Ninth planet, first discovered in 84 years. The first discovered in our country. And that really kicked off this connection of Pluto and northern Arizona. I mean, Percival Lowell had been searching for it, and then subsequent observatory staff for 25 years. It was discovered in 1930, and then since then, astronomers have studied Pluto. A team of astronomers, including many from Lowell, discovered the atmosphere of Pluto in 1988. The first map of Pluto, which was sort of an albedo map showing lighter and darker areas, was created by a team including one of the Lowell scientists here. And so virtually every major discovery having to do with Pluto has ties with northern Arizona. Jim Christie discovered Charon, Pluto's largest moon, in 1978 from photographic plates taken 4 miles away from where Clyde Tombaugh discovered Pluto. Plates taken at the Naval Observatory. So really remarkable, the connection of Flagstaff and Pluto, and that includes the New Horizons mission. When New Horizons flew by in 2015, they had several teams. One team looked at the atmosphere, and one team, was focused on the surface composition. The surface composition team leader was Will Grundy, one of our scientists here. And I'll point out that Alan Stern, the principal investigator, is on our advisory board also. And so just this remarkable connection between Pluto and Flagstaff. And in fact, from pre-search to the dot, to some of the first maps showing the different lighter and darker areas, to the glory shot of New Horizons, all these discoveries are tied to Flagstaff, turning Pluto from a dot to a real world. So whatever we call Pluto, a dwarf planet, and whether a dwarf planet is a type of planet or not, whatever we call it, it's got a remarkable story. And for me, I was working in public programs when Pluto was reclassified. We had so many visitors coming in aghast because Pluto was taken away. Pluto got dumped. It's amazing still today. I hear visitors coming in and say, how could they do that? How could they take Pluto out of the solar system? And, to me, it's a great teaching opportunity that the reclassification of Pluto, first of all, it's not like Pluto was dumped, like, dwarf planets or asteroids or comets are better or worse than planets. It's just this impression that planets are the almighty. It's kind of funny, the human side of it. But also, I think it's a great learning thing because the reclassification of Pluto in some ways shows how science is done. You collect data, you collect more data, and you modify your explanation as you get more data. It also shows how science is not done. Scientists don't sit in a room and vote on what to call things. So, I think the reclassification to me was great because it continues to bring people in to learn the story. And nobody cares about Uranus and Neptune. They were discovered, but Pluto, baby, that was in our country and they took it away. It's controversial. People are still interested in it. So, whatever you want to call it, I don't care. I just think that it's great that, if this is the worst problem we have in the world, what to call this body, we're doing pretty darn well. So I had to talk about Pluto a lot because that's certainly been a big source of research for decades here at the observatory, for a century plus now. Now, some of you, moving on from Pluto, there's a connection to Pluto because Clyde Tombaugh, after he discovered Pluto, he worked here another 14 years. He continued to photograph the night sky looking for other planetary bodies. He, of course, didn't find any more, but he did find, a lot of star clusters and galaxies and other stuff. But he ended up photographing more than 80% of the sky. Well, if you jump ahead a couple decades, an astronomer named Henry Gickless said, we've got this great record of the sky. Let's rephotograph the entire sky that Clyde did, and we'll compare the images we take now to those we took 2 decades ago and measure the position of stars and do a proper motion survey, showing how stars, we have the expected movement of stars and then how they actually move. So let's create this massive catalog, this proper motion survey. Well, again, this blind luck in some ways, while this is going on, while Henry Gickless is starting this project, he reads this newspaper article about a young fellow in Prescott who had discovered a comet. And this young fellow's name was Robert Burnham Jr. And you know his name. I don't think there's anybody here who probably doesn't. And Robert Burnham Jr. was a self-taught astronomer, just like Percival Lowell was, just like Clyde Tombaugh was. Self-taught astronomer. He was brilliant. He was a tragic personality in a lot of ways because he had some personality disorder of some sort. But Henry Gickless invited him to come and work at the observatory because this guy knew the sky. And he spent 20 years working on the proper motion survey. And he was an excellent observer, and he was very meticulous. And, most of us, we think about what we do in our spare time. We have hobbies, but Robert Burnham was single. He was an introvert. While he did he felt comfortable with kids, and he often would show visitors around. He was a kind of an awkward personality. In his spare time, he did astronomy. So in his spare time, he collected rocks and fossils. He did paintings, and he also spent time compiling a book that turned out to be this 2,000-page compendium that we know today is in 3 volumes. That we know today is Burnham's Celestial Handbook. He did this all in his spare time while he was working here at Lowell. And I suspect that the majority of you watching this has a copy or multiple copies of this, even though it's, the data is out of date, star positions and such. This is still a masterful resource. He has so much information about coins, mythology, and other stuff that ties together. It's remarkable. And he did this all in his spare time. Through the years, there's talk about somebody updating this book, but who's going to do it? I mean, I don't know who there is that has the spare time, or if they got money to do this. I don't know anybody. There's nobody that's been interested in doing it because it's just mind-boggling how long it would take to redo this. But I'd like to talk about Robert Burnham because he's such an interesting character, and there's still stories that I haven't quite resolved. When that proper motion survey was done, Henry Gickless retired, and there's many people who look at Lowell as having dumped Burnham, like it was an excuse to get rid of him. I've heard maybe some astronomers were jealous because he had put this handbook together himself and he wasn't a university trained astronomer. On the other end, I've heard that, it was a lean time for the observatory. The funding for the proper motion survey is over. There wasn't any funding. The observatory had offered to put him up temporarily to help out with janitorial duties until something else came along, but he didn't want to do that. I don't know exactly what the story is, but he left the observatory, and the rest of his life was truly tragic. He lived with a sister for a while. He ended up in San Diego, living in a hotel, as it were, and he sold paintings of cats that he made, and he eventually died of heart disease at the age of 61. And he always thought he was going to make his money from the handbook. He sold the rights to Dover, and he never did make a gazillion dollars like he was planning. So he died as a pauper, and nobody knew he had died for years because there was another Robert Burnham that was the editor of Astronomy, Sky and Telescope magazines. That's a different Robert Burnham, but so many people assumed it was the same person. So, anyways, I think I've taken it on myself to talk about Robert Burnham because I wanted to make sure his name is remembered for what he contributed, and it's a fascinating story. So let me move ahead here a little bit, talk about a little bit more science. In the 1960s, as the United States was preparing to go to the moon, the Aeronautical Charts and Information Center, which was a branch of the Air Force, wanted to create maps of the moon in support of the Apollo program. And so for a decade, this moon mapping went on here at the observatory. And during this time, in the mid 1960s and later, all the astronauts who went to the moon ended up coming here to Flagstaff to train, to learn geology, because there's a lot of great geology around here. Several of them came up to Lowell Observatory to learn about the mapping that was being done here. And one of those was Neil Armstrong. This is Neil Armstrong in the corner here. This is one of our scientists, E.C. Slifer, and then Tom Stafford. Tom Stafford's still alive. He flew around the moon on Apollo 10. And so the astronauts did training in this area, including up here at Lowell Observatory. I'm just hitting some of the few examples of research done here. Another type of research done here that I think is really fascinating are occultations. You know, when a planetary body passes in front of a distant star, as an example, and you can measure when the starlight is blinked out and back on, and you can determine the diameter of that body. This is how they discovered the rings of Uranus. This is how they discovered the atmosphere of Pluto. And then, if doing it from the ground wasn't hard enough, they had both the Kuiper Airborne Observatory and then today's version of Airborne Observatory Sophia. Sophia has a 100-inch diameter telescope. It flies at 45,000 feet, and does airborne observing. And they use these for occultations also. It's remarkable the kind of work you can do with this, like discovering the rings of Uranus. So these occultation studies are still going on. One of our astronomers I was just talking to the other day, and he's going to be going down to Australia for another Pluto occultation over the next 6 months or so. So these occultations are pretty neat, and they're really fascinating, I think, because it's really, when we think of old-time exploration, you know, they predict, based on computer modeling and observations, they predict as well as they can where the shadow created by this occultation is going to pass. And then they go, it might be in the middle of Australia, it could be in the middle of Mexico, it could be in the middle of the ocean. They can't observe them all, but they observe these things. A lot of the Pluto occultations are in Australia because Pluto's more south. And so it's really old-time exploration where they get, you know, sometimes they've had guns pulled on them. They've had people that have come and wanted to steal their equipment. They ran out of gas in the middle of nowhere. I mean, really stuff that, you know, it's not like you're going to the telescope observatory, you're there for 4 hours and you go home. It's really, in some cases, almost survival. So it's neat that they still do that kind of observations. Now, through the years, we've done observations. I told you about up here at the main observatory where the Clark 24-inch refractor is, and other telescopes we have up here. Well, by the late 1950s, even though Flagstaff traditionally had dark skies, and in fact, the world's first lighting ordinance was enacted here in Flagstaff in 1958. It was in conjunction with setting up this site, because by the 1950s, our big telescopes were no longer big by standards of the time. We needed to get state-of-the-art telescopes. And if we were going to get them, we had to get a site that was outside of downtown Flagstaff, because the town had grown so much. And so we found a site about 12 miles outside of town. And this is the Anderson Mesa Dark Sky Facility. And this is what it looks like today. There's 4 traditional telescope domes. There's a small one right here that has a 31-inch telescope, originally put in the 1960s for mapping the moon. The biggest is a 72-inch Perkins telescope that came from Ohio in the 1950s. When it was built, it was the 5th largest in the continental US. There's this held to the left held a 24-inch telescope that was used for searching for Earth approaching asteroids for decades. And then the other telescope here is a 42-inch, and that's the John Hall telescope, named in honor of John Hall, our director. And I'll show a picture of that in a second. And then here we have an interferometer. The interferometer has a arrangement of a Y arrangement. So here's one arm. Whoops, you can see my cursor. Here's one arm that goes straight up. There's another arm that goes to the left. Each of the arms is about 250 meters long. There's another arm that comes off to the right. And this instrument is cool. It has several different siderostats located along the arms. They all can point to the same object. They collect light, but they're looking at light from different angles. And so the light is collected, vacuum tubed back to the main building over here, and then all those light patterns, those interference light patterns put together, and you can get really bright images of, you can get images of really bright objects like stars. Using this, you can see spots on other stars. So like we have sunspots, so you can see star spots on other stars. The resolution is remarkable. And this is something neat if you can ever get a tour out here. If we can arrange a tour to see the interferometer, it's really a fabulous instrument to be able to see. So this for years, from the 1960s through early 2000s, was our main research facility. But by the early 2000s, this Perkins telescope, which is 72 inches diameter, wasn't big enough anymore. We needed, again, a bigger telescope to keep up with the modern. So we commissioned, I just put this in, I forgot. This is the whole telescope. This is the outside with this catwalk, and then this is the inside. It's a 42-inch telescope. Our astronomers, one of our astronomers does a lot of cometary work with this. But our newest telescope, the Lowell Discovery Telescope, it's a single mirror. Here's the mirror cell. Oops, here's the mirror cell. It measures 14 feet across, but the glass is only 4 inches thick. And this is what computers can do for us. In the old days, like Lowell Observatory, if you had a piece of glass that wide, it has to be really thick so it doesn't bow under its own weight. But with this mirror, you have 120 instruments called actuators on the underside and the sides. And as the telescope moves, and as that mirror would normally bow under its weight, the actuators are pushing or pulling, keeping pressure on the mirror so that the curvature is exactly the same, no matter how the telescope moves. You couldn't do that before telescopes. What this means is, with the lens only being 4 inches thick, the mirror only being 4 inches thick, it weighs a lot less than it would if it was, a foot thick. And so that changes the size of the telescope, the size of the dome. And it was this project, it cost $53 million to build, but would have been a lot more than that if not for that system. So this is the Lowell Discovery Telescope. And this is our Cadillac telescope, 5th largest in the continental US, and one of the most powerful because it has down here, traditionally on a big research telescope, you have one instrument at a time. So you might have a photometer, or in modern times, a CCD camera. This has what's called an instrument cube. It has 5 different instruments on it. And with the push of a button, in about 30 seconds, that whole instrument cube can spin, and the light path can go from going through one instrument to another. So instead of having to spend a couple days taking off one instrument, putting on another, you can almost simultaneously use 5 different instruments, which is great if we're looking at, say, a comet that we want to look at with different instruments. It's very versatile. We nicknamed the Swiss Army knife of telescopes because it can do so many things in so short a time. Yeah, John, you have a question?
Yeah, what kind of instruments are on the hall?
There's an imager that has the largest possible CCD chip, single piece right now for imaging. It's got there's a speckle spectrometer they use on it periodically. There's another spectrograph they use on it, depending on what they're studying. There's something called NITES, which is an infrared instrument. Most of what they're looking at is visible light, but there is also infrared on there. So it's a variety of instruments. And I can give you some more information on our website. We talk about each instrument, for instance. But it's a variety of things to where we can study anything from, planetary bodies, like small bodies, like asteroids. The youngest, or the nearest asteroid pair was recently announced, and the LDT was used for observations with that. So you can do anything from small bodies in the solar system to, we've got one of our partner institutions are studying blazars with it, and quasars. So it's a variety of things you can do with it. So this is truly, like I said, it's versatile. It allows us to do so many things. This is an important year because this marks the 10th anniversary of first light of the LDT. And so throughout the year, once a month, we're doing a special virtual program highlighting the science being done with this. And in fact, tomorrow night, if you tune in at 7 p.m. our time, so 10 o'clock your time, we'll be talking about small body research with telescope with some of the scientists here. I just want to mention this picture. When we celebrated first light, we had a big gala, and our keynote speaker was Neil Armstrong. And the day after he gave the presentation, we took him out to the telescope, and he was able to do some daytime viewing with the telescope. And this is one of our scientists, Stephen Levine. But this instrument, you can still put an eyepiece on it. And talk about a really cool amateur telescope, 4.3 meter aperture. Just a few weeks ago, and obviously we don't put an eyepiece on there much. When they were commissioning it, they put it on some. And when they're doing maintenance on it, when it's down, they could put it on then also when they're not doing actual science. And so just a couple of weeks ago, we had a big Pluto celebration. Every year we do a Pluto festival celebrating Pluto heritage here. And we had a panel that included Don Johanson, who discovered the fossil hominid Lucy, which is the namesake for the Lucy mission going out to the asteroids right now. He was here. And so it was an engineering night. So we were able to take him, Clyde Tombaugh's son, and some other guests, and we put the eyepiece on, and we're able to do some eyepiece viewing. And there's no description of looking through a 4.3 meter telescope through an eyepiece. But it was really fun to be able to do that.
I have an earlier question, if it's okay to interject it here. You were talking about the geology of the area that was being taught to the lunar astronauts, the Apollo astronauts. So that's a rather famous story, but the geologist that taught them, my question is, did he work for the university, or did he work for the telescope facility, or was he part of NASA in general?
Well, the reason the astronauts came out here, I'll just go back on this a little bit. When NASA was planning the missions to go to the moon, a fellow named Gene Shoemaker, geologist named Gene Shoemaker, he had started the branch of astrogeology of the USGS in California. And the goal was to help prepare to go to the moon, because there's a lot of, we had to learn about the geology. And if we're going to send astronauts that are going to walk around, we had to plan what the mission is going to be and so on. And so Gene Shoemaker, he is the one that proved that meteor crater was in fact caused by an impact. He did his PhD dissertation on that. He co-discovered coesite and other minerals that were evidence of impact. And so he was very familiar with Northern Arizona, and he decided to move the branch of astrogeology from California to Flagstaff because we have the Grand Canyon here. We have the best preserved impact crater on Earth, meteor crater. And we have volcanic fields that are somewhat similar to what they expected to find on the moon. There's a lot of analogies here in Northern Arizona. So he decided to move the USGS here, but he also started to nag NASA and said, you know, the astronauts are a bunch of test pilots. And it was certainly known that they had no interest in doing science. In fact, we're going to the moon to beat the Russians. What does picking up rocks have to do with beating the Russians? I mean, that was a widespread mentality. And Gene Shoemaker and other scientists said, if we're going to go to the moon, whether we're going to beat the Russians or whatever the reason, if we go without doing science, this will be one of the greatest missed opportunities ever. And so we have to do science. And so he convinced NASA, you know, if we're going to send test pilots there, we have to at least train them to learn what rocks to pick up. Otherwise, they're gonna pick up a clod of whatever and think it's all good. And so they did a test out here. The second group of astronauts, Neil Armstrong, Jim Lovell, and others, they came out in 1963. They went to Meteor Crater to see what an actual impact crater looks like. They went to Sunset Crater to study volcanic rocks. They came up to Lowell to see how lunar features are depicted on maps. And then at night, some of them stayed here at Lowell, others went to other observatories in the neighborhood and looked at the moon through telescopes to see what actual lunar features looked like through the telescopes. And even the skeptical astronauts in general said this was really worthwhile. It really allowed us to learn about where we're going. And so NASA, after that, decided to send all the moonbound astronauts to Northern Arizona. So every astronaut who walked on the moon trained here in Flagstaff. It wasn't the only place they trained, but all of them came here for basic geology. And then as they got missions and specific duties, they came here to learn how to drive the rover for the later missions, for instance, or how to collect rocks, how to use instruments, that sort of thing. So the person initially in charge of that was Gene Shoemaker, who had started the USGS here in town. But there were a lot of other geologists involved. Some of them worked with NASA. Most of them were with the USGS. Some of them worked at the university here in town. And then when they went to places like Lowell Observatory, they worked with the astronomers here to learn about impact science and that sort of thing. And so there was a lot of training done by a lot of different people, but they were mostly affiliated with the USGS. And it's a great story because not only did that happen in the 1960s, but modern day NASA astronauts are still coming to Flagstaff for training for Artemis mission. And who knows if and when Artemis will happen. It seems like it's on a good track. But those astronauts who are going there have all trained, done some basic geology training of Flagstaff. In some cases, the same place where the Apollo astronauts did. So it's kind of a neat heritage.
That's a great story.
I could talk all day about just the moon mapping astronaut training because it's cool. So, but that's a not so brief overview of that.
Thank you.
So let me go on a little bit more research, then I'll wrap up with outreach. Another project that's really has so much potential right now involves Deborah Fisher of Yale, Joe Lama here at the observatory and their team. And they've built a spectrograph that goes onto the Lowell Discovery Telescope. And it's capable of seeing planets the size of Earth. And so they were commissioning this instrument, and now they're using it. And they're looking at they're not only searching for Earth-sized planets, and the goal is to find 100 Earth-sized planets, but also to study the stars, which are sun-like stars. And all of this, ultimately we're looking for life on other worlds. That's one of the goals, but also to understand more about Earth in our solar system and the sun. Because for most of the time, our sample size was one solar system. Now we're able to study solar systems elsewhere. How typical is our solar system? How typical is Earth? How typical is the sun? These are the kind of questions they're asking with this research. And then we also not only do observational stuff, but over at Northern Arizona University, they have a cryogenics lab where they can recreate. This is a really Rube Goldberg-like setup here, but they're able to recreate the frigid conditions of outer space. And that is able to inform a lot of research, like with New Horizons, comparing what they find in the laboratory of what they actually find with observations. So this stuff is really neat also. And then one more science thing I want to talk about that I think is really neat, because again, this is something we can all associate with, I think. And this has to do with the search for meteorites. This is Nick Moskovitz, who studies small bodies. One of his projects is that he's created this network of these little boxes that have cameras. And these are just off-the-shelf security cameras that anybody can buy. They're, I don't know, $100 a piece. They're not that expensive. He gets a cluster of these and he puts a covering over this, a clear covering. But there's one on the roof of the building that I'm in. There's about half a dozen around Northern Arizona. And all these things do is at nighttime, they all just record the night sky. They're security cameras. They just record the sky. But if there's a bright meteor that somebody notices, we can go back on the video, and based on looking at all the different cameras for all the different stations, they can project where a bright meteor would impact. They can triangulate the position. And just last weekend, we went out for the first time, this group, I was part of this group, we went to Gallup, a field near Gallup where they had projected a meteorite had landed. We didn't find any pieces, but it was a good learning experience of how to refine the search area and such. But an associated team that Nick works with, I don't know, 3 years ago, they found meteorite pieces using this technique in Eastern Arizona. So as time goes on, this very simple technique, they're going to be finding, not only finding pieces of meteorite, but they'll know where it came from, when it landed, and its trajectory and everything else. So it's really, pretty neat how meteor science is really going to be evolving faster, I think. So I think I told you I would briefly talk about research, but it gets away because there's so much great stuff. One more thing I want to mention before I go into the outreach is dark skies. Flagstaff has this great history of dark skies. When Percival Lowell came here, one of the reasons he came was for dark skies, to get away from city lights of the east. At the time, Flagstaff's nickname happened to be the Skylight City because of its elevation and the brilliance of the stars. When we were bringing out that new telescope, the Perkins telescope, in the late 1950s, the scientists bringing it here, they found a great site for it, but realized that there were some spotlights from in town that were shining out where this new observatory would be. And so one of our retired scientists, who used to be mayor of Flagstaff, talked to his buddies at the city, and they created an ordinance. And as it turns out, that was the first outdoor lighting ordinance in the world, right here in Flagstaff, to do that observing. By 2001, more dark skies legislation had happened in the community, not only the town, but also the county. And in 2001, Flagstaff was named the world's first international dark sky city. And Flagstaff continues today to be a leader in dark sky protection. And it's remarkable. One of the satisfying things for me is, Flagstaff has grown to where we now have 70,000 plus people. And the observatory, we look down on Flagstaff. I mean, downtown is right next to us. It's less than a mile away. We're on top of a mesa. We look down right at the lights of Flagstaff. And yet you know, when the season is right, we can look up and easily see the Milky Way. And it's so satisfying to see people from eastern cities, for instance. I've seen this several times where people are looking up and wondering what the clouds are. They thought it was supposed to be clear tonight. No, that's the Milky Way. And I've seen people cry because they've never seen dark skies. And I'm preaching to the choir here of the value of dark skies, but it's something that we all can really embrace. And for me to be able to see that on a nightly basis is really special. Yep, John.
There's a question in the chat asking if you know what the Bortle number is for the area of the.
Oh, I don't. I can check on that and get and send that to you later on. I don't know what the number is offhand.
Thanks.
So our director is the head of the AAS Committee on Light Pollution, and we still play a prominent role in protecting the skies. So that's a big part. I think we talk about the science that's been done here, but I think it's also, you know, the leadership with protecting dark skies that has really taken off around the world, I think, because it's not just an astronomy problem. We know now it's, you know, artificial light affects life and so many things in negative ways. So it's really something that a lot more people are interested in. Now, one more thing I wanted to mention, I'll just whiz through some pictures, is first of all, again, what's the point of doing research unless we share it with people? And it's the most satisfying thing is to bring people up here, let them look through telescopes, and it's like they're making the discovery themselves. They're co-discovering it. They can look through a telescope themselves. And all of you know that you do star parties, you know how satisfying it is when people look through telescopes for the first time and they're hooked. It's really inspiring. So that education, excuse me, just a second. That education is a huge part of what we do here. And so those of you who have been here recognize that this is our main visitor attraction for years, the 24-inch refractor. And this brought in a lot of people. Through the years, in recent years, we have more than 100,000 visitors coming up per year. We're bursting at the seams. So we've become well known because a lot of visitors come here. We're easy to get to. Another reason Lowell has become well known, in addition to the easy access for visitors, and of course, the important science discoveries like Pluto and recessional velocity, the expanding universe, is that the observatory has been featured on, gosh, name an educational show on TV, and Lowell's been featured. Back in the 1950s, Walt Disney created the TV show to promote his park. And E.C. Slifer was featured on one of those episodes, Mars and Beyond. Carl Sagan, in the original Mars series, there's the episode Blues for a Red Planet. This is him, a still of that video of Cosmos, him at the telescope. This is Leonard Nimoy, who had a TV show back in the day, and he's interviewing Carolyn Shoemaker, wife of Gene Shoemaker, and at one time she discovered more comets than anybody else in the world. A great story in her own right, a housewife that at the age of 50 got into astronomy and went on to discover dozens of comets. So they did programming up here. Bill Nye the Science Guy did an episode up here back in my younger days. And even, what's that?
Cleveland Indians.
Yes, Cleveland Guardians now, of course, but
that's true.
But even a side note to this, that how Lowell is part of pulp culture, whether intentional or not. Years ago, I was watching The Big Bang Theory, waiting for my family to get home, and periodically I'd watch it, and I thought I saw a telescope in the background. So one day, I'm waiting for the family. I see it, I pause it, and there's the Clark telescope on the poster. So in season 1, in the bedroom of Sheldon and Leonard is the Clark telescope. Here's a close-up. This is a picture of the TV I took. And this is a picture of an astronomer named Leonard Martin. This picture was taken in the 1980s. that's on their door. So Lowell has infiltrated educational TV. We've done popular programs. We do this Pluto event. This is Alan Stern, and a local brewery every year makes a special brew for us. And this year it was Pluto Porter. This year they did Lowell Lager. And in fact, I regret to say that this is empty, but this is the can they made this year. And this is the iconic, I'm getting a glare, but the iconic picture of Percival Lowell sitting at the telescope, and there's a little beer can in his hand he's holding. So that's their take on it. So Flagstaff has become known world around because of the science, because of the dark skies, because of all these TV shows, and it's led to so much visitation that a few years ago, we decided we have to expand our operation. We don't have enough parking. We don't have enough things for people to do. So the line is 24-inch refractor could get really long. And so we decided to first build, we decided to ultimately we want to build a new visitor facility that instead of accommodating comfortably 70,000, we can accommodate 100,000 or 300,000 visitors a year. And so that's going to take years to develop. In the meantime, let's build this, what's called this open deck observatory, the Giovanni Open Deck Observatory. And we completed this a couple of years ago. It's up in the vicinity of where the Pluto Discovery Telescope is. This whole hangar rolls back and it unveils 6 telescopes. These telescopes are all permanently mounted. And this is designed, well, we could do research with a couple of these. This is designed for the public so that we have the 24-inch refractor. We have other telescopes, but we also have this facility that any given night, all these telescopes are open. I thought I'd just show you quickly what these are. They're all designed to do different things. So here we have a wide field refractor where we can look at, open star clusters and that sort of thing. I think to me, the most gorgeous telescope is this specially made instrument. It was made in England, this Moonraker, and it has this Victorian look to kind of as a throwback to the Clark refractor. It's an 8-inch, and this is great for looking at planetary objects, especially. And I want to point out one other thing that, I said this is designed for public use. So essentially we have a star party every night. We have these 6 telescopes, 24-inch refractor and others. And to make this easier for visitors, this mount, with a push of a button, the mount can take the whole telescope down or up. And the telescope stays pointed at the object. So if you have somebody in a wheelchair, you lower it and it's still on the object. If you have somebody really tall, they don't have to climb the ladder in the dark. You just raise it and it's at their level. And so that's been a really great innovation for this. We have 2 plane waves, a 14-inch and then this 17-inch. And both of these are attached to cameras. One has a mainland cam system on it. And one of them we have attached to a spectrograph so we can show visitors what scientists actually do. They don't look through eyepieces. They use instruments like a spectrograph. And so we can project images we're getting from the spectrograph to show people what we actually do. And then the other one has the mainland cam system where we can project that on the screen. We want to make sure people can look through eyepieces because that's really cool. But also by projecting on the screen, we can have one of our astronomers looking at an object and explaining what he's looking at. So you can really have good teaching moments. So it's really ideal for that. And then the other telescopes, we've got a 16-inch Meade and then a 32-inch Dob. And this is technically our largest telescope by aperture on site. So this variety of telescopes allows us to show visitors a variety of things on any given night. So it really is kind of a star party atmosphere. And we opened this in the fall of 2019. And we opened it with Charlie Duke, who walked on the moon, Apollo 16, and his wife. They were the keynotes at this event. We opened it up, and in fact, I was the one that I thought it would be neat to have an astronaut, so I tracked him down. But I was able to present him with asteroid Charlie Duke that one of our astronomers had discovered, and we named it in his honor. So we opened this in the fall, and we knew the first real busy season was going to be spring break, but that would have been spring break 2020 when COVID hit. And so we had to close, and we're just now fully reopened as of a week ago. So we're able to really use this instrument, this facility. And in fact, just a couple of nights ago, we had 700 people up here. And that's going to be more of typical nights now that we're reopened full time. And this is one more telescope we have. This is a 24-inch plane wave. Again, a fabulous instrument. The plane waves are really working out well for us. The last thing I'll mention, I said that was phase one of expanding the visitor experience. Phase two is this new Astronomy Discovery Center. And this is going to be located, it's even a different parking lot. So if you remember coming up to Lowell, you'll no longer go to the parking lot you have since 1994. It's a brand new parking lot. It's going to be visible from kind of where the Pluto Discovery Telescope is. And this new facility is 3 stories. And to me, the coolest part of the top, because it's going to be a couple 100-seat open area. And we talked about putting a planetarium in, but instead, we're the home of dark skies. Let's use the real thing. So it's this theater type setup to look at the night sky. The seats are heated because it does get darn chilly here. And so it'll be accessible, unless it's snowing or raining, it's accessible any given night, whether it's cold or warm or whatever. And that's going to be a really neat element of this. This is what construction looked like just 2 days ago. So you can kind of start seeing, this is the perimeter of the building right here. And then the parking is way back here. So when you come, if you come, who was coming in 2023, you'll see a lot of building. And then 2024, we'll be opening this up. So like I said, this is, there's a lot to talk about with Lowell, and I easily can talk a long time about it because I love the place. And I love it because there's so many great things going on here, but it's a place that really cherishes partnerships and cherishes the idea that we're doing this for everybody. This is why, we invite you to come and visit as a group or as individuals, come and visit and see what's going on, because we want to share this. And it's such a great story, the heritage of research, the heritage of education that goes on here, and the heritage of preserving the dark skies. There's a lot of really great stories here. And throw in a lot of really great individual discoveries like Pluto and the expanding universe. And there's just so many stories to talk about and so many personalities. So with that, I'm going to stop talking. That's depending on your definition of brief, that's a brief introduction to Lowell Observatory and the goings on here. And I'd be glad to take any questions, or if anybody wants to discuss anything about this, I'd be glad to talk about it now.
Thank you, Kevin. It was great. Yeah, a lot of comments in the chat just saying, I can't wait to see the parts I missed because I have to leave. So it's a good thing we are recording it. Oh, good. Just got a new one in the chat. Where is all the funding coming from?
Well, Lowell is a nonprofit, and so I believe it's begging, borrowing, and stealing. I think that's where the funding is coming from. But when I started here in 1995, our development department was one person, and they had just started a membership program. Today we have, I think it's 11 full-time people, or 10 or 11 or something like that. And so we are aggressively and actively going after grants, donations. Our membership program has a couple thousand members or so. We're working with corporations. We work with governments at different levels for funding. And so it's coming from a lot of different sources. Our astronomers in general still get the get the funding for their research from writing grants, the traditional grant writing process, to National Science Foundation, the Naval Observatory, different organizations. But in about 5 years or so, that money, they'll still be getting some money from that, but our goal is to generate income to cover the research through our public programs. With this new visitor facility, based on visitation trends, our visitation is skyrocketing. And when we have a place to put everybody, there's going to be a lot more people. We anticipate tripling our attendance, just like when we expanded years ago. And with that, we have admissions income, we have gift shop income, we have many new members, and then again we have a lot of very strong donor program, and there's a lot of really fun creative things, like with the Open Deck Observatory. One of the fundraising ideas was people could sponsor signs that had either a scientific quote or a scientific formula, like E equals MC squared, or a quote by, name a scientist. And we sold all the available space. It was well over 100 signs, I think. And those were at, I don't know, $1,000 a piece or something like that.
Oh, wow.
So people can have their names on a sign, and it's an exhibit itself by going around and reading all these quotes. People can have their names there, and we're able to collect funding to help fund the project. We're doing the same thing with the visitor facility we're building now. So the money comes from a lot of different sources. We also have an endowment that Percival Lowell left that for years we drew about 30% of our operating budget from, but now we're moving toward a time when we don't use that for any operating budget. It's more for specialty projects, like if we need to upgrade an instrument or something like that, and we have that set aside to do that sort of thing. So to do all this, when I started, we had about 50 people on staff, and now we have 130 or so, and it's growing rapidly.
Do you have a Cleveland connection?
I was born in Medina County,
Ah,
so I don't know, 20 miles outside of Cleveland. And so you can see my Cleveland Buckeyes pennant there. That was a Negro League baseball team. And I'm a Guardians, Cavaliers, Browns fan.
I was born in Cleveland.
Where'd you go to school?
And the very last town that's still in the same county, Olmsted Falls.
Olmsted Falls, yeah.
Yep.
That's a pretty place too.
Yeah, very tiny.
My mom went to Lakewood, and then my dad went to East High, which I think is still around, somewhere in East Cleveland back in the day.
Used to live in Birdland up in Lakewood.
Yeah,
All the streets named after birds.
yeah. And in fact, at Warner and Swayze had a facility there for years. They built a lot of the mounts and stuff for telescopes.
Yeah, what is the mount for year 24? Is it a Warner and Swayze?
It's a Warner and Swayze.
Yep,
Alvin
Ozark.
Clark, they designed the telescope itself and did the lens and everything. But yeah.
Yeah, we have a 20-inch at our home university here in my alma mater, Wesleyan, and it's a Warner and Swayze as well.
Okay, yeah.
Any final other questions for Kevin from anyone? We did that for, if you track this stuff for your marketing, we had 22 people.
Okay, that's great.
Yeah.
Well, it's great talking to everybody, and there's so many things to talk about at Lowell, but again, an open invitation to come and visit. Let me know when you're coming, and it's always fun to be able to share this in person, because there's so much really great heritage that everybody should see that has an interest.
Let me throw that right back at you. If you have another aspect of the research and stuff that you hadn't talked about, you're certainly welcome to come back again.
Yeah,
Okay.
yeah, absolutely. We're, we don't do meetings during the summer, but, from September on, we're always, the welcome mat is always out.
Well, I'm also glad to link you up with some of our astronomers. We have a range of quality of speakers. Most of them are very good. Some are very excellent. And so I'd be glad to line up, whoever might be a point person, I could introduce you via email to some of those if you're looking for speakers.
Oh, that'd be
Oh,
great.
certainly. Yeah,
I will,
Chris and
yeah,
I do most of it.
yeah, we will be in touch.
Okay,
That's great. Thank you. And thank you for this. This was fascinating. It's
Indeed.
yeah, yeah. And we're getting, as John mentioned, I mean, I'm seeing the chats pop by, and a lot of people are saying thank you, excellent presentation. So you're getting a lot of compliments.
well, thanks for the opportunity to chat. And if you ever need anything from us, let us know.
Sure will.
Will do.
Sure will.
Certainly we'll be in touch.
Okay,
right.
thanks.